tutoring handouts that was given like 2 sessions ago. Or can you have your hands up? Periodic table of the elements, and I really like this table because it has like color, has the elements color coded, and they're like nice. I'll give you the periodic table for your exam, so you'll see that it's much smaller, not that nice as this one. So yeah, I want to make sure all of you have this, and also the information about the tutoring. So if you have any problems with the course, you can schedule an appointment with a tutor and go to them and ask questions. And you also have your SI-class leaders that they listed, and they list the sessions that they're holding every session. And I also posted those in the course syllabus, and I asked you in your first homework assignment. So you have like several resources. Don't let the problems or your questions that you have being unanswered. You have several resources as well as myself. So before I start today's lecture, do you guys have any questions about the course in general, or like homework assignments, or good? So I posted the homework assignment, like on Saturday morning, so you have access to that. And I realized that I don't want to send you guys several announcements and just like remind you every minute that you have a homework due. So I'm going to send the reminder tomorrow, a day before the homework assignment. So make sure to complete it in one session. So just study for each homework assignment, and then when you're done studying, just go to the homework assignment, and you also can use your notes and everything. And as I told you, attendance is mandatory in the class unless you are not feeling well, or for any other reasons, you have like a doctor appointment, or like you should go to DMV, or like any other reasons that you cannot come to the class. As long as you email me and let me know, I'll have your absence excused. And also there is a reason that I asked you to attend the class. The main reason is to make sure that you understand the materials, and as well as attendance, I asked you guys to also devote your attention to the class, because if you just attend the class, but you're just like on your laptop watching a movie, or like, and I saw that happening before, I audited some classes, and on the back, I see some students, like just watching a movie. So don't do that. Or like, I saw some students that they are on their phone and just like texting you during the whole class. And I know that you may use your phone or like laptop to take notes. That's totally fine, So anyhow that you learn better, do that. But just make sure that devote your attention to the class. By any means that you want to do that, that's totally fine. You can use whatever you want, but pay attention to the class. Any question about that, or attendance in general? Okay. So, again, a reminder that lab starts this week, and any session that you register, that is your session. But again, if you wake up in the morning, you have food poisoning, and you couldn't go to the Tuesday's lab, let your TA know that you have an excused absence and try to make up for it. Because you only can have 2 excused absences. After that, even if you have like 5 excused absences, 2 of them doesn't affect your grade, the other 3 would be 0. And the reason being, because it's because of the nature of the labs, and you should run experiments. And imagine one student went to all 12 labs, and they run experiments, and then they had difficulties, but overcame those and all that. And then there's one student that they had like 8 excused absences, and they went to only 2 labs. Should they get the same grade? So it's just like because of the nature of the lab. So 2 excused absences, is allowed, and you should communicate that with your TA too. So it doesn't mean that you can have 2 absences. You should communicate that you will be missing the lab. So just a reminder about that. And we talked about, measurements and problems, and specifically measurements we talked about. So can anyone tell me, and also you have the answer here to help you, but can anyone tell me how do we write scientific notations and why do we use them? So why shouldn't we just, write numbers as they are? Why do we use scientific notation? Yes?
We use scientific notations to write very large and very small numbers.
Yes. So if I have a number and I tell you the number is like, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, several zeros, like 10 to the power of 12 zeros in front of them. So it's really hard to write that number, And then if you want to write that number 3 times, it's just like so burdensome. It's like, it's not efficient. So we use scientific notation for really large or really small numbers. That is the main reason we use them. So how do we write scientific notations? So if I give you this number here and then ask you that write the scientific notation, how do we do that? Anyone? Yes?
You've got to move the decimal point however many places until you're in front of at least like the first number, the first digit.
Yeah?
And then you put, you put the number 1.2 and then put it to the power, or you put 10 to the power of whichever direction you're going.
Exactly. So you write your number as a number between 1 to 10. And it can be 1 point something, depending on your number, but the number should be between 1 and 10. And it would be having a decimal point after the first digit that you write here, right? So this is like important. And then you write it multiply by 10 to the power of, negative or positive, depending on your number. If you're working with really small numbers, like 0.0000, these are like really small numbers, the power would be negative. If the number is like 1 million, 1 billion, or like 12 trillion, the number is really big, the exponent, the power would be positive. And this number here, you count between how much you changed the decimal point, right? To give you samples, I asked you guys to write scientific notation for the first number. So write that on a piece of paper, and then I'll give you the answer, and then we see if you got it right or wrong. And I'm going to ask you 2 or 3 questions about scientific notation in your exam, so make sure to understand it good. So first of all, if I want to write this number as a scientific notation, so what is the first step? To write this number as a number between 1 to 10, right? So how do I write that?
2.456.
Exactly, right? And you know that when we have like zeros after the decimal point, it's based on the number, it's not the new number. But in the laboratory, if you want to show the precision, you might put like more zeros. But when we write the scientific notation, we don't have to write, zeros in front of this, right? Does that make sense? Okay, so we just write this part. Okay. And then I write multiply by 10 to the power. Before I write the rest, is the power positive or negative?
Positive.
Is that clear why?
Yeah.
Why?
Um,
Yeah, just say.
Because on that side of the decimal point.
Exactly. And also because it's a large number. So remember, large numbers have like positive powers, but you can also count the decimal points. So here, you don't see a decimal point in this number here. So it means that it was like decimal 0. Let me just distinguish this. Okay, right? When a number doesn't have a decimal, if I tell you, that I weighed some gold and it's like 10 grams, and I don't tell you anything else, it means like 10.0, right? I mean, when I don't record that number, it means that my scale didn't have like that much of precision. But in general, if I have like 1, it means that it was like 1.0 if I don't have any decimal point. Does that make sense what I'm saying? So what I'm saying is that the decimal point here is, after the last 0. And then you wrote this number as 2.4, right? You change the decimal point to here, right? And then you count you count the difference between these two decimal points. 1, 2, 3, 4, 5, 6, 7. So this would be the scientific notation of this number. Does that make sense? So the first thing is that you write the number as a number between 1 to 10, and then multiply by 10 to the power of something. If the number is large, the power is positive. If the number is really small, the power is negative. So even if you just know these things, these two things, your exam is multiple choice question. You can just eliminate 2 answers immediately and then choose between the rest of the 2 answers, right? And then to get it completely right, you just count how much or how many digits you changed the decimal point. Any question about this? So can you write the second one and then we check together? Can anyone tell me what they wrote?
for the next one, right?
Uh-huh.
5.7 times 10 to negative 7.
Did everyone get this? Does anyone have different number? So you see, we write this number as a number between 1 and 10. So if I give you this in the exam and I say 57 multiplied by 10 to the power of minus 7. Even without calculating the decimal point and all that, that's not a scientific notation because 57 is not between 1 and 10, right? And then the decimal point, now we shift it here and then we count, 1, 2, 3, 4, 5, 6, 7. And then the number is small, so the power is negative. And this is how we write it. Is that clear? So can you guys write the next one? Can anyone tell me what they wrote?
2.57 times 10 to the power of negative 4.
Did everyone get this one? So the number, we write it between 1 to 10, so it would be 2.57. And we write it 10 to the power of something, and then the power is negative because its number is small. And then we count 1, 2, 3, 4. We change the decimal point 4 to the right. What about the next one? Can anyone tell me that?
5.8 times 10 to the 6.
Right? So here, when we don't have decimal point, it means that it was here. And then we shifted to here. So 1, 2, 3, 4, 5, 6. And then the number is large, so the power would be positive, and the number between 1 and 10 would be 5.8. Any question about scientific notation? Okay. So we talked about writing numbers so that they reflect precision. And we talked about if we report a number, you have your lab being started this week, and then next week you have like the measurement lab, and when you want to report the numbers, if you have a ruler that it has like only, till here, right? So it has like, just up to 1 millimeter. So if you report the number as like, if I tell you that how much or like, what is the length of this coin, and then if you read the number here, and then you tell me, okay, the number is like 20, so here is like 25, right, between 20 and 30, and then here is like 24. So if you tell me the number is like 24 point like 4, 5, 6, I will tell you, how did you get that from this ruler, right? The precision of this ruler is just like, 1 millimeter. So you can say, basically it's like 24 or 25, right? If I gave you more precise ruler, you can like report the number with more precision. But we cannot read this number based on this ruler, right? And if I tell you, if you read the number as like 24.6, right? So the last digit is estimated. And we talked about this before too, right? That when we report the numbers, the last digit is always estimated. Because we don't know exactly what is that. It can be 24, it can be 25, right? Based on this ruler. So the last digit is estimated. Any question about that? So if I give you this number, 1295.456. So which digit is estimated in this number? 6th, right? The others are like, we're sure, they are like precise, they are exact, but the last digit is estimated. Any question about that? Okay. And then it's another example that your book gave, and I just like included that here. So if we want to like measure gold, and then if I tell, and these are like measuring like statue and like copper and stuff, or like another element. But just like I just want to demonstrate the point that if we say that, we have like 10 grams of gold, it means that, we had like the scale that we had could just measure up to this much of precision, and then we talk about significant figures like in the next slide. And then if we use more precise balance, we may report it as 10.0 gram, like here. The scale is like a little more accurate or precise. And then if you have like another scale that is, even more accurate, we may measure it as like 10.00 gram. So depending on the scale or like measuring device that we're using, we can have like different levels of accuracy. Okay, now I'll give you guys a little break and let's do the attendance. Does everyone have the link? Can I go to the next slide, or are you still using the slide? Good? Okay. And again, you know, if you had difficulty to putting your name, just raise your hand right now, so I just come to your table and then get your name. Okay. Okay, everyone else is good? Oh, okay. Okay. So, now let's go to the next slide. So here I included a video of like, you know, math review basically to working with like decimal points. So if you know already how to work and deduct, you know, or like multiply, or like work with like numbers with decimal places, just like you can skip this video. But if you have difficulty, I encourage you to just like watch the video. And now we're going to talk about significant figures. Any questions? Okay, so this is the definition, and I ask this always in the exams, so I'm just like telling you, and also in your homework and quiz problems. So the non-place holding digits in a measurement are significant figures or significant digits. And kind of like to be more clear, I also borrowed the definition from like this link, but it's basically the same as the above, you know. The non-place holding digits, those that are not simply making the decimal point, are called significant figures. And in the next slides, I tell you the rules of significant figures, and this definition becomes more clear. And significant figures represent the precision of a measured quantity. So previously, I told you about the ruler, like 24.1, and then how much precision this number has and all that. And in general, significant figures, you know, represent the precision of a measured quantity. And I give this always in the exam, and I said they represent the precision of a measured quantity. Scientific figures, trailing zeros, decimal places, significant figures. And lots of students confuse that with scientific notation. Scientific notation has nothing to do with the precision of a measured quantity. It's just like a way that we write really large numbers or small numbers. But significant figures tells us how much of precision we have. And the greater the number of significant figures, the greater the precision of the measurement. And again, I give this true or false in the exam. The greater the number of significant figures, the less precision we have. True or false? Again, if I tell you, yeah, the greater the number of significant figures, the less precision we have.
False.
Great, thank you. Okay, so now here are the rules, and these are really important to know when working with significant figures and also for your exam. So to determine the number of significant figures in a number, we follow these rules. All non-zero digits are significant. For instance, in 1.05, 1 and 5 are significant. Or like in like 0.0110, 1 and 1 are significant. So all non-zero digits are significant. Is that clear? Okay, so just remember these one by one, because now we're adding rules. So all non-zero digits are significant. Interior zeros, so what are they? Zeros between two numbers are significant. For instance, if I have like 4.0208, these two zeros, the zeros between two numbers are significant. Or like 50.1. Again, 0 is between two non-zero digits. So the zeros between two numbers or like interior zeros are significant. Is that clear? Trailing zeros. What are trailing zeros? Zeros to the right of a non-zero number that fall after a decimal point are significant. For instance, 5.10 or like 3.00. So again, remember the measurement, if you go to the lab and then we report a number as like 3.00, it means that we had a scale and we could measure that matter that we measured with that much of precision. So these numbers, these zeros, are significant. And we call those trailing zeros. Trailing zeros that fall before a decimal point are significant. For instance, like 50.00 or like 1700.24. These zeros are also significant. Leading zeros are not significant. So now let's see what are leading zeros. Zeros to the left of the first non-zero number. For instance, if you have like 0.0005, this number has only one significant digit or significant figure. So leading zeros, zeros to the left of the first non-zero number, so these zeros are not significant. So everything that I was telling so far, and I'm going to say, they are like significant, but leading zeros are not significant. And like 90% of the students last semester, I gave exactly the same sentence that I'm going to include in the study guide too. And almost everyone got that wrong. So the number 0.0005 has just one significant digit. So if I tell you in the exam how many significant digits this number has, how many? 1. So leading zeros to the left of the, so this is like the first non-zero number, right? The zeros before that are not significant. Any questions so far? Good. Trailing zeros at the end of a number but before an implied decimal point are ambiguous and should be avoided by using scientific notation. What that means is that if I tell you a number, report a number like 350, that is, this zero, is like ambiguous, and we don't know how many significant figures this number has. And we should write scientific notations like 3.5 multiplied by 10 to the power of 2, or 3.50 multiplied by 10 to the power of 3, to say that, okay, this number has like 2 significant figures or 3 significant figures. But if I tell you that how many significant figures 350 has, it's not clear. And we use scientific notation to show how many significant figures this number has. Does that make sense? Any questions? Okay. So these are like some rules, and I'm going to ask them as like true or false in your homework, quiz, exam, any materials that I'll post. So when a number is expressed in scientific notation, all trailing zeros are significant. We just saw the previous example, right? If I have like 3.50 multiplied by 10 to the power of 2, that zero is significant. It means that we measured, that quantity with that much of precision. So here, all these trailing zeros are significant. So if I ask you how many significant figures this number has, we learned that like all non-zero digits are significant, and then these trailing zeros are also significant. So it would be like 1, 2, 3, 4, 5, 6. This number has 6 significant figures. Does that make sense? And exact numbers have an unlimited number of significant figures. So exact numbers, in the next slide, I have like the definitions, that what are they. So the exact number is the opposite of a measured quantity. You go to the laboratory, you measure, some, for instance, weight of copper. Or like you have a ruler, you measure the size of like this book, or like you have measuring tape, you measure the length of this room, and so on and so forth, So those are measured quantities. But exact number, I tell you, I exactly have one book here. This is like an exact number. Or I say, we have exactly 102 students in this class right now. That is an exact number, right? We cannot have like 102.5 students. That doesn't mean, unless we have like half a student. No, doesn't make sense. Or like, 102.1, we have like 102 students and a leg. It just doesn't make any sense. So exact numbers are like, counting of objects or things or like people in general, right? And the other thing is like when we define quantities, and I have, for instance, 1 foot is like 12 inch. This 12 is an exact number. If I tell, 1 foot is like 12.00 inch, you're like, what does that mean? It doesn't mean anything because I didn't measure this 12. It's an exact number. So, and here, your book listed, and I just borrowed, from your book, exact numbers originate from these resources. So exact counting of discrete numbers, as we said, like 3 atoms. So when we say, and as you remember, exact numbers have unlimited number of significant figures. So if I say like 3 atoms, it means like 3.0000 and unlimited till infinity. So if I tell you how many in the following sentence, 101 students or like 102 students are present in CHEM101 class. So how many significant figures the number 102 has? What is the answer? Unlimited, right? Exact numbers have unlimited number of significant figures. And defined quantities, such as the number of centimeters in 1 meter. Because 100 centimeters is defined as 1 meter, we say 100.0000 centimeters equals to 1 meter. So they have like unlimited number of significant digits or significant figures. Integral numbers that are part of an equation. For example, in the equation radius equals diameter over 2, the number 2 is exact and therefore has an unlimited number of significant figures. And then this is another question that was like giving students headaches last semester. So I was saying exact numbers originate from all the resources, all these sources except, exact counting of discrete numbers, defined quantities, integral numbers that are part of an equation, measured quantities. Which one? Okay, I repeat the question. Exact numbers originate from all these resources or sources except exact counting of discrete numbers, integral numbers that are part of an equation, defined quantities, or measured quantities. Measured quantities, right? Because measured quantities are not exact, right? But the other ones are like exact numbers. Any question about exact numbers, significant figures, scientific notations? Good? Okay, now we want to talk about rounding. How many of you know what is rounding? If I say you want to round a number. Okay, few of you. So when we want to round the number, I'll tell you to round this number to like 5 significant figures or like to 2 significant figures. If I have like the number as like 1.12, I don't know, 49, depending on, so first of all, how many significant figures this number has? 5, exactly. 5 significant digits or figures, because all the non-zero numbers or digits are like significant. So I can tell you that I want to round this number up to 4 significant digits, or like up to 2 significant digits, or like 3, depending on how much precision we want to keep when we round the number, right? So we round down if the last or leftmost digit dropped is 4 or less. We round up if the last or leftmost digit dropped is 5 or more. So if I want to round this number to 4 significant digits or figures, right? So it means that I want to drop this number, right? But I look at this number here, you know. So if I just write this 4, you know, this number is roughly 1.125, right? And this is how we round. This number that we, you know, want to drop, you know, is more than 5, so we round up. So if this number, you know, is 5 or more, we go 1 up. Does that make sense? But for instance, if I had like 1.1241, if I wanted to round to 4 significant digits, I would write this number as like 1.124. I would just like drop. So I would like round down. Does that make sense? So here we have like how many significant figures this number has? 3, right? We have like 2, 3, 3, right? 1, 2, 3. So we want to round it to 2 significant figures. So we look at this number. This number, I guess I highlight here. This number is more than 5 or less than 5. Less, right? So we just like drop it. So it would be like 2.3. But here, this number, is it more than 5 or less than 5? So we add 1 to this 3. So we round up. It would be like 3.4. Does that make sense? Any questions? So what is like 2.34 if we want to round it to 2 significant figures? What would that be? Can anyone tell me why? Okay, I didn't hear what you guys said, but I assume it's because like 4 is less than 5, right? Was that the same thing that you guys said? Yeah. Okay. Yes. So what about 2.35? If I want to round it to 2 significant figures, what would that be?
2.4.
Because this number, you know, as we said, if it's 5 or more, we round up. So it would be 2.4. And this is something really important, and I'm going to ask you in like your quiz and homework and also most probably your exam. For calculations involving multiple steps, we round only the final answer. We do not round the intermediate results. This prevents small rounding errors from affecting the final answer. So if you have like multiple steps for your question, you know. So imagine we have like 12.1 multiplied by 50.02, you know, divided by 4.08, you know. If you want to do these calculations, what some students do is that, you know, they put this in their calculator and then they round the number that they get and then divide it by this number. What I ask you to do is that put everything in the calculator, and then when you got the answer, then round the number. Does that make sense? So don't round the intermediate step because you're losing accuracy. Any question about that? So I may ask you in your homework problem that for calculations involving multiple steps, we should round all the intermediate steps. we also should round the final step. True or false?
Well,
Right? We only round the final step, not the intermediate steps. Now we learned about significant figures, but how do we use them in the calculations, right? So we have like multiplication, division, and also we have like addition and then deduction, right? So in general, first of all, if you went to the laboratory, you measure some quantities, and then you have like two significant figures in your calculations or like things that you reported, and then you're doing some mathematical operations on them, your answers should reflect the significant figures that you worked with. Does that make sense? So if I have a ruler and then I do some measurement and I say, okay, this object, I don't know, like this pen is, the size is like 10.1 millimeter. Imagine this is that. And then I say plus like 2.3. Again, my ruler had like this much of precision. And then if I, do some mathematical operations and I tell you the answer now is like 12.399. You look at me and say, okay, how did you get this number based on that? Your precision was like 1 decimal point, right? 1 digit after the decimal point. So I should say, okay, it's 12.4, not this. Although these are like the same numbers, but the numbers that I measured, they had like 1 digit precision after the decimal point, right? So in general, when you're doing mathematical operations with your numbers, you should keep the accuracy. And there are like 2 rules. One is for multiplication, division. The other is for addition, subtraction. So first of all, we should not lose or gain precision during mathematical operations. And for multiplication and division, when you do the mathematical operations, you look at the significant figures. And then you count the significant figures in the numbers. And then your answer should have the same number of significant digits as the number with the fewest significant digits. Meaning that if I have like 5.02, it has like 3 significant figures. And then this number has like 5 significant figures. And then this number is like 2 significant figures, right? The answer should have like significant figures corresponding to the one with the fewest. So this one, 2, is the fewest, right? 3, 5, 2. 2 is the fewest. So your answer here should have like 2 significant figures. Does that make sense? So what you do, first of all, remember, don't round the, so if you multiply 5.02 by 89.665, don't round that. Use the same number, multiply that by 0.10. But when you got the number, you see that, okay, what is the fewest significant figure, the number with the fewest significant digits, and that is the 0.10. It has 2 significant figures, so your answer should have 2 significant figures. And this question, I gave it to the students last semester, almost everyone got it wrong. Because they just put the number in the calculator and then they got that number and marked like 45.0118. Remember, you should have like, significant figures corresponding to the number with the fewest significant figures. And now for like more addition and subtraction, we don't look at significant figures anymore. We look at decimal places. And again, we choose the one that has like the fewest, but not significant figures, fewest decimal places. So imagine we have like 5.47. It has like 2 decimal places, right? 1, 2. And this number, it has like 1, 2, 3. 3 decimal places. Didn't mean to eliminate that. Anyway, 2.651. 1, 2, 3, 3 decimal places, right? So the number that we report, when you put the number in the calculator would be this, but we should have like 2 decimal places. The number that you report should have 2 decimal places, so it would be 9.21. For subtraction and addition, we don't look at significant figures anymore. Does that make sense? Any questions? Okay, now let's do these calculations together. So put these numbers in your calculators or your phone if you don't have your calculator. Remember, for your exams, you should bring the calculator because you cannot use your phone. But for our class activities, you can just use your phone or laptop. So put these numbers in your calculators. And I also wrote the number here, but just let's see, The other thing, first of all, remember, in your exams, read all the answers for multiple choice questions, even if you're 100% sure. And also pay attention to the questions, which one is like, saying, which one of the following has the fewest number of significant digits, or like which one is not the answer, Pay attention to that. Also, when you put the numbers in calculator, make sure to put the right numbers. Sometimes when I'm designing the tests, I get an odd number. I realize that instead of 5.02, I point like 5.28. And then I put the same answer in as one of the options too, because I feel like if I make the mistake, some other people may make the mistakes that I did. So anyway, did anyone get this number here? Okay. Now, can anyone tell me that if I want to write the answer or the answer that you choose in the exam, what is that? So how many significant digits this number has?
3.
How many this one has? How many this one has? So the answer should have 2 significant digits. What is it?
25.
Great. So now for this one, so what is the answer here? How many significant digits should it have? 3, right? These zeros are significant too, right? So what is the answer? Right? And then you should round up here because this number is 9, right? Does that make sense? What about this one? Did I write this? Or... right? Because this number is not significant here, right? So what about the next one? $1.52, right? We should have like 3 significant digits. Does that make sense?
Yeah.
What about the next one?
1.4.9.
So we have like 2, 1, 3, so we should have like 1 digit decimal places, right? So and then the next one would be like 8.66 because we have like 2 digits after the decimal point, 3, so it would be like 2 digits after the decimal point. Any questions about any of this? Okay, I'll let you guys go. Okay.